Hello everyone, welcome to a new video. Today we will look into gradient descent. We have heard this term many a times during interviews and while studying. So what is it? It is basically an optimizational algorithm using the cost function to update the weights to reduce loss. Now in this case, the cost function is used as a gauge using which we are updating the weights and also biases. Weights and biases to reduce the loss. Now, for gradient descent to work, the functions at first must fulfill certain criteria. Not all cost functions are eligible for gradient descent to work on it. Now, what are the criteria? Number one, the cost function must be differentiable. Now, few examples of differentiable functions are cos x, sin x, and many more. Whereas an example of a non-differentiable function would be mod x at x equals 0. This is non-differentiable. This is differentiable. Now the second criteria would be the function should be convex. The cost function must be convex. Now what does a convex function look like? We have a function which looks like this. If we take any 2 points on the curve and draw lines from each of those points, those two lines should intersect at a point which is over the curve. Only then it would be convex. So it's a convex function. In mathematical terms, we might define it as a function f of x is convex if the second order derivative of f of x is greater than 0. An example of it would be 2x square plus x plus 1. If this happens to be f of x, then the first order derivative of x of the function would be 4x plus 1. The second order derivative would be 4, which is greater than 0. Hence, we see the function is convex. Now, once these two criteria are fulfilled, we can apply gradient descent on the cost function. Now, how does gradient descent work? We have a convex function like this. Now, the gradient descent algorithm starts at any random point, arbitrary point. Say it starts over here. What it does is it differentiates the function at this point, gets the slope, and updates it or guides the algorithm to move in the direction in order to reduce the loss function. Over here we see the minima is at this point. This is the minima, and our aim is to reach at this point. So what gradient descent does is, after finding the algorithm, after finding the gradient at this point, It guides it it guides the weights or updates the weights to reduce the loss or towards the minima. It takes a jump after updating. Once the update has been done, again the process is repeated, the slope is found and the direction of the update is ascertained, and again it takes a jump. Now as we go towards the minima, the rate of jumps reduce. Why is it so? Think of it like a ball. If this ball is rolling down the slope, what happens is once the slope flattens out, the rate at which the ball is moving reduces. Similarly, it happens when we are going to reach the minima. What happens is the slope or the gradient becomes very small, and hence the rate of update or the rate at which the weights have been updated also reduces. Now the working formula of gradient descent is something like this. Now Wn plus 1 would be the updated weights. Wn would be the old weight. Now this is called a learning rate. So what does learning rate do? Now again we have a similar convex function. Now say we have a high learning rate. Learning rate is high. What learning rate does is the updates or the jumps that we have, those the rate of jump that is determined by the learning rate. Now if we have a very high learning rate, the machine learns faster or updates faster if learning rate is high. Now if it is so, is it always beneficial to have a very high learning rate? Well, the answer is no. The reason being, if the learning rate is high, we might end up skipping the minima altogether. We might just jump over the minima. So, a very high learning rate is not always advisable. Now, what happens if we have a very low learning rate? The jumps in that case will be very small. So, a very low learning rate leads to a slow learning, is very slow learning, and it might end up not reaching the minima altogether. It might just die out. So our aim is to have an optimal learning rate, or even better, it would be if the learning rate is also a learnable parameter. There are many algorithms which use the learning rate and updates the learning rate as well as the learning goes on. So the learning rate is not the same at which is at the beginning and at the end. The learning rate also changes. Now this is how the learning happens. That is, the weights and biases are updated in order for us to reduce the loss. Now there are a few kinds of gradient descent. One being stochastic gradient descent or SGD. SGD, it runs an epoch for each example and updates the weights So it has a very less memory requirement because it is running an epoch for one example of the data set, then updating the weight for the next epoch itself. So it has a very less memory requirement. The next is batch gradient descent. What happens is the entire data point or data set is used to run a epoch, and only after the entire run is complete the weights are updated. So it is updated after the entire run is complete for the next epoch. So it is much slower because it is storing the updates for each and every run and then updating it finally. So it's slower and more memory consuming. I wouldn't say it is slower, it would be more memory consuming. The third is a mini batch. So what is it? So instead of the entire data set in a mini batch gradient descent, we define the data size, that is, we define the data, the number of data points that will be used to run one epoch, and then it is updated. So again, a batch is defined by us to run a epoch. Run an epoch. So it runs an epoch for the number of data points we have mentioned in a mini batch, and then it updates the values for the next run. They are SGD, batch gradient descent, and mini batch gradient descent. So we covered gradient descent today. In the next tutorial, we'll go into applying gradient descent in Python for a neural network. Thank you and hope you liked it. Don't forget to like, share and subscribe. Bye.